بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الديناميكا اسمه مبادئ الشغل والطاقة. طبعا إن في علاقة بين الشغل والطاقة، محتاجين إحنا طبعا الورك دان ده محتاج قوة ومحتاج سرعة. أيضا في علاقة بين الشغل والطاقة هندرسها في الدرس ده ونشوف أمثلة كتيرة مهمة جدا جدا على الورك والإنرجي. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in dynamic. What is the title? Principle of work and energy. The change in kinetic energy of particle when move from initial position to final position is equal to the work done. Remember, what is the meaning work done? Dear student, change of kinetic energy particle when move from initial position to final position. This is called work done. By the force acting on the earth during the displacement between these two positions. Look at the work done, change of kinetic energy, T minus T naught. The proof. Since, dear student, kinetic energy equal half mv square. M is mass, v is velocity. Kinetic energy is represented by capital T, half mv square. By using calculus differentiation dt over dt respect to time t equal d over dt half mv square. Dear student, we have t equals half mv square. By using differentiation left hand side and right hand side respect to the time t, dt over dt equal dt d over dt half mv square. What is the constant? Excellent student. The constant in right hand side half m. M is mass. It's constant. Then the right hand side becomes half m times 2v dv over dt. We find differentiation velocity respect to time t. Dear student, then right hand side is equals mv dv over dt. What is the differentiation velocity respect to time t? X and student, acceleration a. Then right hand side equals m dot v dot a, or m times v times a equals m dot a dot v. What you mean m dot a? X and student, the force F times V. F is force, V differentiation of displacement respect to time t equal F ds over dt. Then by using cross multiplication, dt equals F ds. Then integration from t naught to t dt equal the integration of from s naught to s f ds. By using integration left hand side, right hand side. Left hand side kinetic energy, right hand side f ds. Then t from t naught to t equals w or the work. Then the change of kinetic energy equals the work done. The change of the kinetic energy equal the work done. Dear student, now we are translate to important example. Body of mass 400 gram is projected vertically upward with velocity 25 meters per second. Dear student, remember, body, its mass 400 gram. projected vertically upward with velocity 25 meter per second. What is the kinetic energy when it becomes at height 15 meter from the point of projection? Solution. Look at the student. Look at the opposite figure. C is unit vector, vertically direction upward. The distance between or the highest is 15 meter. Look at, dear student, the kinetic energy, change of kinetic energy T minus T naught equals the work done. Then T minus T naught equals negative mg times S. What is the M? Is 400. By using divided 1000 to convert it to kilogram. Then T minus half multiply 0.4 times 25 squared velocity equals what? Negative 0.4 times 9.8 times 15. Look at left hand side and right hand side. What is the unknown? T. Then kinetic energy T minus 125 equals negative 58.8. Then T equals 125 minus 58.8 equals 66.2 joule. Another example. Dear student, we know that kinetic energy by another solution V squared equals V naught squared plus 2GS. By using substitution V naught equal 25, G 9.8, S distant equal 15. V squared equals what? 625 minus 294 equals 331. Then velocity by using kinetic energy T equals half mv squared, half times m 0.4, v squared 331, then T equals 66.2 joule. Then we find the velocity from the motion, the rule of the motion. After that, substitution about kinetic energy equal half mv squared, half times 0.4 times 331 equals 66.2 joule. Another example. A bullet of mass 300 gram is fired horizontally with velocity 147 meter per second on vertical barrier. This barrier of thickness 7 centimeter. The bullet comes out the barrier with velocity 49 meter per second. Find the resistance force of the barrier to the motion of the bullet in kilogram dot weight. What is the required, dear student? Find the resistance force of what? Of the barrier to the motion of the bullet in kilogram weight. Look at solution. Dear student, look at the solution. Look at, dear student, consider C is unit vector in the direction of the motion of the bullet. Look at T minus T naught equals work done. Remember the relation between work done and energy, change of energy, T minus T naught equals W, or the work done. Therefore, T minus T naught equals negative R times S. What is the meaning of R? Resistance of the bullet. S is the distance. Therefore, by using substitution, left hand side becomes half times 0.3 times 49 power 2 equals negative half times 0.3 times 147 power 2 equals what? Negative R times 0.07. Then the R resistance equals 41,160 Newton divided by 9.8 to find by kilogram dot watt. Then resistance of the pullet is 4,200 kilogram dot watt. Another example. A car of mass 1.92 ton moves horizontal road with uniform acceleration at instant. Then its velocity became 90 km per hour. After covering distance 50 km, the resistance to the motion equals 400 kilogram dot watt. Calculate the force of engine of the car. Dear student, what is required? The force of engine of the car. Solution. Dear student, look at C is unit vector in direction of motion of car. Look at, dear student, V naught equals 18 times 5 over 18 equal 5 meter per second. But V final velocity is 90. The velocity after the car covers distance became 90. Multiply by 5 over 18 equals 25 meter per second. Then we know that change of kinetic energy equals the work done. T minus T naught equals W. Then half M multiply bracket contains V square minus V naught square equal F minus R times S. What is the F minus R? Look at the student. The opposite graph, the force of the car in direction C vector, but resistance of R in opposite the F force. Then F minus R times S equals change of kinetic energy. Why? Because we know that change of kinetic energy equal work done. What is the change of kinetic energy? Half M multiply bracket F V power 2 minus V square, V naught square. What is the work done? Equal F times S. What is the F? In this case, we have force and resistance. What is the force? Is F minus R. Multiply S. Then, by using substitution, we know that half multiply 1960 multiply 25 square minus 5 square inside bracket equals 5 minus 400 inside bracket multiply 9.8 times 50. Then F minus 400 equals 1,200 kilogram watt. Then the force is 1,600 kilogram watt. This is the force of the car. Another example. Hammer of mass 1.5 kilogram moves horizontally to head. A nail of mass 75 gram in wall. Dear student, we have a hammer of mass 1.5 kilogram moves horizontal to hit a nail of mass 75. Mass of what? Of nail 75 gram in a wall. If the velocity of the hammer at the instant of hitting the nail's head equals 105 centimeter per second, what is required? Find the common velocity of the hammer and the nail after the hitting directly. Remember, the student, common velocity of what? Hammer and nail. After hitting directly. Number 2, find the lost kinetic energy due to impact measured in joule to the nearest hundredth. Remember, dear student, the second required, very important. Why? Because you want the lost kinetic energy. What is the lost kinetic energy? Excellent student. Kinetic energy before impact minus kinetic energy after impact. The third required, how many hits are needed for the nail penetrates in the wall? Distance 3.5 centimeter. How many hits are needed for the nail penetrates in the wall? A distance 3.5 centimeter. If the resistance of the wall to the motion of the nail equals 157.5 Newton. Look at solution. Dear student, we know that kinetic energy before impact equal kinetic energy after impact. M1 V1 plus M2 V2 equals M1 plus M2 inside bracket multiply V dash. Dear student, in our life we have a hammer and nail. We need to hit a hammer to nail. The nail moves a distance in the wall. We know that kinetic energy before collision or before impact equals kinetic energy after impact. We have a hammer and nail. M1 V1 plus M2 V2, this before kinetic energy before impact. M1 plus M2 inside bracket times V dash is kinetic energy after impact. Dear student, look at the solution. 1 V1 plus M2 V2 equals M1 plus M2 inside bracket V dash. Then by using substitution, M1 equals 75 over 1000 because M1 in gram divided 1000 multiply V1 equals 0. M2 equals 1.5 times V2 105 over 100 equals M1 plus M2 times V dash. What's the V dash? Is 1 meter per second. The common velocity of hammer and the nail after hitting becomes 1 meter per second. Dear student, V dash is the common velocity of the hammer and nail after hitting. Look at kinetic energy before equal kinetic energy after. After hitting, the common velocity becomes 1 meter per second. The last kinetic energy, X and sodium, means kinetic energy before impact minus kinetic energy after impact. Then we know that the lost kinetic energy will have times 1.5 times 1.05 inside bracket power 2 this kinetic energy before impact minus kinetic energy after impact equals half times 1.575 times 1 squared. Answer is 0.039375 equals 0.04 joule. Then the lost kinetic energy equals what? Kinetic energy before impact minus kinetic energy after impact. This lost kinetic energy when hammer used to hit a nail must be equals 0.04 joule. What is the change in kinetic energy? Equals the work done by the resistance. Remember this rule. Work done by resistance equal change of kinetic energy. Then by using this rule, have m multiply bracket v square minus u square equal negative r times s. What is the r? Resistance of the force. S is distance. M mass, v final velocity, u initial velocity. By using half times 1.575 multiply 0 minus 1 for all power 2. Why? Because final velocity equal 0 equal negative 1.57.5 times s. What is s? The distance which you need it in when hammer hit to nail, then s equals 0.005 meter equals 0.5 centimeter. The nail needs to penetrate a distance 3.45 centimeter in the wall. Then the number of hits, we divided 3.5 over 0.5 equals 7 hits. The number of hits of nail equals 7 hits. Another example. A bullet is fired horizontally with velocity 540 km per hour towards a piece of wood. Piece of wood to stay in it at a depth 20 centimeter. Note that and think with me, dear student. We have bullet fired horizontally with velocity 540 km per hour towards a piece of wood to stay in it at depth 20 centimeter or moving in the wall 20 centimeter distant. If the same bullet is fired with the same velocity towards constant target of the same kind of wood of thickness 15 centimeter, find the velocity with which the bullet will come out the target, supposing that the resistance is constant. Remember, dear student, what is the required? The required is find the velocity with which the bullet will come out the target, supposing that resistance is constant. Look at solution. Look at the bullet. What is the c vector, unit vector in direction of the bullet? Look at direction of resistance is the opposite the motion, or in r vector opposite c vector. C vector consider unit vector in direction of motion of bullet, but r opposite the motion of the bullet. In the first case, dear student, we know that change of kinetic energy equals the work done. We have T minus T no equals W or work done. Then by using substitution, 0 minus half times M times 540 times 5 over 18 for all power square equals this right left hand side equal right hand side. Negative R times 0.2. R is resistance of the force, but M is the mass. Then negative half M times 22,500 equals negative R times 0.2. This equation number 1. We have two unknown, M and R. M represents the mass, R represents the resistance force. In the second case, change of kinetic energy equal work done by using left hand side. After substitution, half M multiply V square minus 22,500 equals negative R times 0.5. This equation number 2. By using dividing equation 2 by equation 1, we get 4V squared minus 9,000 equals negative 67,500. After that, 4V squared equals 22,500 divided by 4, and find square root V squared equals 5,625. Then by using square root, the velocity is 75 meter per second. Another example. Body of mass 2 kilogram moves with uniform velocity of magnitude 3 root 10 meter per second. A resistance force of magnitude 6x square Newton, where x is displacement which the body covers under the action of the resistance meter act on it. Find the velocity of the body and its kinetic energy when x equal 3. Solution. Dear student, the work done in this case, we find integration from 0 to 3 force ds equals, what is the f? 6x square. dx from integration from 0 to 3, negative 6 power 2 becomes negative 6 power x power 3 over 3 equal negative 2x power 3 from 0 and 3. By using substitution when x equals 3 and when x equals 0, then subtract, then the work done is negative 54 joule. Since change of kinetic energy equal W, then half M multiply bracket V squared minus V naught squared equals the work done equals half times V squared times 2, half times 2 times V squared minus 3 root 10 squared equals negative 54. By using V squared minus 90 equals negative 54, then V squared equals what? Equals 36. Then the velocity is 6 meter per second. Dear student, by the end of the lesson, we know that the relation between work done and kinetic of energy. Dear student, I am very happy to spend such time with you. Don't forget, math simple, think, work, produce. Goodbye.